Welcome dreamers to one more scintillating session of the Daily Dose. And I have very scintillating trick to solve number of numericals from G code and M code. We know that recently very interesting questions were asked based on a G code and typically G01. It is called as rapid positioning or rapid travel of the tool. So let's say that suppose I want to start a machining operation, and before the machining operation start, can I say that my tool has to call to the point P1 where I am interested to create a milling slot. But before the start of machining operation, my tool will be anywhere. Idealistic condition will be there, my tool will be at the origin, and realistic condition will be there, tool will be anywhere. So I'm selecting one point where my current position of the tool is. So I'll say that this is exactly equal to my current location of the tool. So my tool has to travel from this current location to point P1 where coordinate is 5, 5. And once it reaches the point P1, I'll start performing my machining operation. Now, whenever tool is moving from current location to point P1, tool is not in contact with workpiece and tool is not performing machining operation. It is called as idle movement. It is called as what? A IDLE, idle movement. And such an idle movement of the tool will be controlled by Z00. So while covering idle movement, naturally, my tool should take shortest path and my tool should move with a maximum feed velocity. And that's why a G00 rapid positioning of the tool is developed. But whenever tool is moving, the tool will take a resultant feed because there will be a certain feed given across x-axis and certain feed given across y-axis. So whenever we talk about feed, can I say that in NC and CNC machine, there might be chances that feed rate across x and the y-axis can be different or feed rate across x and y-axis can be same. Anything can happen. And now a beautiful question is coming. Calculate the time required for movement of tool when the feed rates are given across axis and point location is given. Let's take one example that suppose I want to travel to the point P. The coordinate of point P is exactly 50, 25, right? This is what exactly coordinate. And my tool is there at 0, 0. That is exactly equal to origin. So O point, my tool is there 0, 0. I have to travel to this point. And once I reach to the point P, I'll start performing machining operation. So this has to be covered by Z00. That is called as rapid positioning of the tool. And there is certain feed rate is given. So feed rate across x-axis and the y-axis can be different, and feed rate across y-axis and x-axis can be different or same. So I'm selecting one example here. Feed rate across x-axis is exactly feed rate across y-axis is exactly equal to 25 mm per minute. Right, fine. Now once my tool is at the origin, so initially simultaneous axis movement will be given. So when the simultaneous axis movement is given, tool will follow in such a path, in such a way that it will cover certain distance across x and certain distance across y-axis. So after 1 minute, tool will reach to the point where it must have been covered 25 mm across x and 25 mm across y. So therefore, can I say that tool will travel like that? Tool will travel to such a point. I'll say that the point Q where x-axis coordinate is 25 and y-axis coordinate is 25. So this is the path my tool will travel. This is the path. This is called as resultant feed. Tool will take and travel to this point. How much distance it has to travel across x-axis? 25 mm. How much distance it has to travel across y-axis? 25. Absolutely correct. 25 mm distance it has to travel. And how much time will be required to reach to this point? 1 minute will be required. Yes, because feed velocity is 1 minute per 25 mm per minute. So this is 25. This is 25. This distance will be covered in 1 minute. So now if you closely observe that, my whatever distance my tool has to travel to reach to the point P, that y-axis distance I want to travel is exactly equal to 25 and x-axis distance which is travel is 50. So out of that, y distance is completely covered. So I don't require to travel anything about y-axis, and therefore the feed velocity across y-axis will be now cut down, will be now closed. And now from this point Q, only one axis feed movement will be given, and now tool will travel only across x-axis. So only one axis feed will be given and the tool will travel to the location P. How much is the remaining distance? The remaining distance is 25. Already 25 is covered. So this remaining distance of 25 mm will be covered in 1 minute. So how much time will be required for tool to travel from O to the P? So total time of machining operation or total time of movement of tool is exactly 2 minutes. Now is it going to do like that in GATE examination? Calculate how is the path followed, then tool will reach at this point and then no. You do one thing, that simple drama is there. How much distance you want to travel across x-axis? 50 mm. And what is the feed velocity across x-axis? 25 mm per minute. So calculate time required for movement across x-axis is distance to be traveled divided by feed rate across x-axis. So answer will come exactly 2 minutes. In the same manner, calculate how much time will be required to travel across y-axis. That is how much time will be required to cover y-axis distance. That is 25 divided by 25. That is exactly equal to 1 minute. So it is very simple drama that to cover a x-axis distance we require 2 minutes and to cover y-axis distance we require 1 minute. without covering both axes, I cannot reach to the point P, and therefore the time required to movement of point P is exactly equal to maximum out of these two. Is what? Maximum out of these two. So when question comes in GATE examination, you don't require to trace any kind of path. You just see that how much total distance I want to travel across X and what is speed velocity. Calculate time to movement, time to move along X axis, and calculate time to move across Y axis, and out of that whichever is maximum, that will be movement time, that will be time required for movement of tool, that will be time required for movement of tool, that will be answer. So therefore I'll say that my answer will be time of movement is exactly maximum out of what? Maximum out of tau x comma tau y. Maximum out of what? Tau x comma tau y. This is the way by which these numericals has to be solved. Right, fine. Thank you.